Okay, good morning. Welcome back. In the last class, we have already discussed about some standards of 802.11. Today, I am going to discuss another standards like 802.11g applies to wireless LANs and is used for transmission over short distances at up to 54 Mbps in the 2.4 GHz bands. 802.11n builds upon previous 802.11 standards by adding multiple input, multiple output MIMO. The additional transmitter and receiver antennas allows for increased data throughput through spatial multiplexing and increased range by exploiting the spatial diversity through coding scheme like Alamotive coding. And the real speed would be 100 megabits and so up to 4 to 5 times faster than 802.11g. Similarly, 802.11 AC or Wi-Fi 5 builds upon previous 802.11 standards, and particularly the 802.11 standard to deliver data rates of 433 Mbps per spatial stream or 1.3 Gbps in the 3 antennas design. 802.11 SC Web 2 is an update for the original 802.11 SC spec that uses MIMO technology and other advancement to help increase theoretical maximum wireless speed for the space of 6.93 Gbps. So these are the generally the standards used in the 802.11. Next, these are 802.11 AD is a wireless specification under development that will operate in the 60 GHz frequency band and offer much higher transfer rates than previous 802.11. Again, 802.11 AH, also known as Wi-Fi Halo or 802.11, which is the fast Wi-Fi specification to operate in the frequency bands below 1 gigahertz or 900 megahertz, and it has a range of nearly twice that of other Wi-Fi technologies. 802.11 are also called the fast basic service sets transition. Supports Wi-Fi handoff between access point to enable to voice IP roaming on a Wi-Fi network with 802.1x authentication. 802.1x not to be confused with 802.11x. Again, the 802.11x or Wi-Fi 6 improves on Wi-Fi 5 with more speeds. Next, come to the IEEE 802.11 architecture. Two network architectures are defined in 802.11 standard. One is your infrastructure network, another one is your point-to-point or ad hoc network. In infrastructure network is the network architecture for providing communication between wireless clients and wire network resource, and the transition of data from the wireless to wire medium occurs by an access point. An access point and its associated wireless clients define the coverage area. Together, all the devices form a basic service set. Next is your point-to-point or ad hoc network. An ad hoc network is the architecture that is used to support mutual communication between wireless clients. Typically, an ad hoc network is created spontaneously and does not support access to wire networks. An ad hoc network does not require an access point. And this is the 802.11 architecture. And this IEEE 802.11 supports 3 basic topology for wireless LAN, and the independent basic service set IBSS, basic service set BSS, and the extended service set ESS. The MAC layer supports implementation of IBCS, basic service set, and ESS configuration. And this is again the independent first one is the independent basic service set. The IBSS configuration is referred to as independent configuration or an ad hoc network, An IBSS configuration is analogous to a peer-to-peer office network in which no single node is required to act as server. Like peer-to-peer, every service or every node having the independent configuration. IBSS wireless LAN include a number of nodes or wireless stations that communicate directly with one another on ad hoc peer-to-peer basis. Generally, IBSS implementation cover a limited area and are not connected to any large network. An IBSS is typically a short-lived network with a small number of stations that is created for a particular purpose. Next is your basic service set. The basic service set configuration relies on an access point that acts as the logical server for a single wireless LAN cell or channel. Communication between station 1 and station 4 actually flow from station 1 to AP1, that means access point 1, and then from access point 1 to access point 2, and then from access point to access point 4, and finally access point 4 to station 4. An access point performs a bridging function and connects multiple wireless LAN cells or channels and connects wireless LAN cells to a wired enterprise LAN. And another was your extended service set. In this, when the two BSS are connected with itself, is known as the extended service configuration. That means in this architecture, look, there are two BSS, right? There are two BSS. When the two BSS are communicate with each other through this distribution system, it is known as the ESS, right? So that is the ESS. Consists of multiple basic service sets cells that can be linked by either wire or wireless backbones called a distributed system. Now, IEEE 802.11 supports ESS configuration which multiple cells use the same channel and configuration in which multiple cells use different channels to boost aggregate throughput. So to network the equipment outside the ESS, the ESS and all of its mobile stations appear to be a single MAC layer network where all stations are physically stationary. Thus the ESS hides the mobility of the mobile stations from everything outside the ESS. Next come to the MAC layer. The medium access control is a sub-layer of data link layer. It defines who can use the network medium when multiple computers are trying to access it simultaneously. The 802.11 family use a MAC layer known as CSMA and CA. In CSMA CA, a wireless node that wants to transmit performs the following sequence. Listen on desired channel. If channel is desired algorithms in the MAC layer. First you listen the desired channel. If channel is busy, node waits until transmission stops, then a further contention periods. If the channel is still idle at the end of the contention period, the node transmits the packet. So again, this is the algorithm during transmission in the MAC layer. First you listen the desired channel. What is the status of the desired channel, whether it is free or not. If channel is busy, node waits until transmission stops, then a further contention period. If the channel is still idle at the end of the contention period, the node transmits the packet. What is the contention? That is the time gap between the transmitting of one packet and the transmitting of another packet. So that is the contention period. And these are the security regarding the IEEE 802.11. The security services are provided largely by the web or wireless equivalent privacy protocol, and the three basic security services defined by IEEE. First one is authentication. In authentication, again there are two types: hierarchy authentication and open system authentication, confidentiality and integrity. So in the security there are three types, then and difference: authentication, confidentiality and the integrity. In the authentication, the hierarchy authentication that means we can authenticate it to share a key and the open system authentication. So today for this, and in the next class we'll discuss about the security. Okay, thank you to all.